In the previous example, we saw a Fourier series which only had sine terms. And of course, you can easily imagine that there might be series which only have cosine terms. And these are very interesting special cases, and they are called Fourier sine series and Fourier cosine series. And how this goes is very simple. If you have an odd function, you remember odd means f of minus x is minus f of x, so the minus sign gets out. Then you get a pure sine series, because a sine, of course, is also an odd function. So if you have an odd function, then the series, the Fourier series, will consist of odd functions too. And then for even functions, right, even means f of x is f of minus x, then you only get cosine. So then the cosine functions are even functions, and they approximate an even function. So it all makes a lot of sense. So these are called Fourier sine and Fourier cosine series. But we can even make this a little bit further if we have functions which are defined on an interval from 0 to L. Because if the function is defined on 0L, I can do both. I can do a sine series and I can do a cosine series. Okay, that's a bit surprising. So earlier we had functions on minus L to L, and then we did the Fourier series. But if it's only defined on half of it, so let's from 0 to L, I can do even or odd extensions, right? Remember, we could do extensions. So in this case, so here let's say this is my function f of x. I can do the odd extension, and then let's call this minus L and L. If I do the odd extension, I get the sine series. If I do the even extension, this was this function and then this from minus L to L, then I get the cosine series. And you see, these functions are different on the left, okay? So the functions are different, period. They're different on the left. The odd one has a jump here, the even one doesn't. But they are the same functions on the right. So from 0 to L, they are the same functions, which means both series work, the sine series or the cosine series. The coefficients can be computed by the known formulas. So the coefficient Bn will be the formula 1 over L integral from minus L to L f times sine, but we have to use the odd extension here. Now if f is odd and sine is odd, together it is even, so I can simplify this to be an integral from 0 to L, where I get a 2 here, I get this twice, and then I can use the original function times sine. Okay, so for the Fourier sine series, I get away by integrating from 0 to L if I multiply the coefficient by 2. And how is it for the even extension? Well, so the a coefficients, oh yeah, here I need one more space, so the a coefficients, the a0 or the an, you use the even extension in the general formula from minus L to L. And then the same happens. Now here f even is an even function, cosine is an even function, so together we get it twice. But then we can get away with integrating from 0 to L, the original function. Or here we kind of get a 2, but we also have a 2 in the denominator, right? So they're cancelled, and the same thing happens for the a0s. So if we have a function from 0 to L, we can extend it in an even way or in an odd way, and then we can find a sine series for that function or a cosine series for that function, depending on what we want.